Setting up an off-grid solar station for your farm is a game changer for maintaining tools and lighting without dragging extension cords across the property. Lithium iron phosphate batteries are the gold standard for this because they offer a high cycle life 3000 plus and can be discharged almost completely without damage. An important option which has not been covered in this discussion is solar BLDC water pumps, which are useful for a fully off-grid farm operation when piped water supply is not available. They can operate directly from solar panels without the support of a battery. Primary components needed are solar panels. Monocrystalline panels are recommended for their efficiency in limited spaces. MPPT charge controller. Unlike older pulse width modulation controllers, MPPT or maximum power point tracking can harvest up to 30% more power and allows for precise lithium iron phosphate battery charging profiles. And you need the core lithium iron phosphate battery. A 12 volt 100 ampere hour battery is a common starting point, providing roughly 1.28 kilowatt hour of energy. The battery which I showed earlier has 1.38 kilowatt hour of energy, and you need a pure sine wave inverter, which is essential if you plan to run AC powered tools like drill, chargers or grinders. A 2000 watt inverter is usually sufficient for most handheld farm tools. Before buying equipment, estimate your daily usage to ensure your battery doesn't die mid-task. Here's a simple example. Cordless drill charger 60 watt, 2 hours of usage 120 watt hour. LED shop light 20 watt, 4 hours used 80 watt hour. Small angle grinder 700 watt, hours used 0.5 hours, so 350 watt hour. Total daily need 550 watt hour. To cover 550 watt hour, a 12 volt 100 Ah battery, that is 1280 watt hour total, is perfect, as it gives you about 2 days of autonomy even if it is cloudy. Lithium iron phosphate batteries are sensitive to overvoltage. You must program your charge controller with these specific settings. Bulk or absorption voltage 14.4 volts to 14.6 volts for a 12 volt system. Float voltage 13.5 volts to 13.6 volt. Lithium iron phosphate battery doesn't need a heavy float, but this keeps it topped off while under load. Absorption time set to 0 to 15 minutes. Unlike lead acid, lithium doesn't need a long soak time. Low voltage disconnect. This is quite important. 11 volts to 11.5 volts to protect the cells from deep discharge. Please check the manufacturer's specifications and follow it. There is some difference in the battery which I have shown according to the manufacturer. Mount the MPPT charge controller. Keep the charge controller and battery in a ventilated weatherproof box like a solar shed or a modified job site box. Connect battery first. This is very important. Always connect the battery to the charge controller before the solar panels. This allows the controller to boot up and recognize the system voltage, which could be 12 volts or 24 volts. Install fuses, highly important because you don't want a fire by short circuit. Place a fuse or circuit breaker between the battery and the controller, as well as another one between the battery and the inverter. Then connect solar panels. Wire your panels to the controller's photovoltaic input. Use 10 AWG or 8 AWG solar tray cable to minimize voltage drop over distance. Regions which can have sub-zero temperature, unlike my region which is at 11 degree north latitude and near sea level, lithium iron phosphate batteries cannot be charged below 0 degrees centigrade or 32 degrees Fahrenheit. If your farm experiences freezing winters, ensure your battery has low temperature cutoff built into its battery management system, or keep it in an insulated heated enclosure. You can see the temperature displayed on the battery management system shown here.